Hello, today we're going to attempt the following complex number polynomial question. So the question goes like this. Given that the complex polynomial, a complex number z equals -2 plus 7i is a root to the equation z cubed plus 6z squared plus 61z plus 106 equals 0. Find the real root to the equation. Okay, so we've got this polynomial here. And what we can see is this polynomial has real coefficients. So the coefficients are 6, 61, 106, and there's a 1 in front of the z cubed as well. So the polynomial has real coefficients. And it has a complex root z equals -2 plus 7i. What it turns out is we can use the complex conjugate root theorem. The complex conjugate root theorem says if z is a root, then the conjugate of z is also a root, where the polynomial must have real coefficients. Okay, so if z is a root, then the conjugate of z is also a root. And we can apply this theorem because this polynomial in z has real coefficients. So what is the conjugate of z? The conjugate of z is equal to the conjugate of -2 plus 7i, and this is equal to -2 minus 7i. So now we found two roots of this cubic equation. So all we have to do is to find the final real root of this equation. So what we can do with the two roots we already have is we can use these to construct linear factors of this cubic. So z equals -2 plus 7i. It corresponds to a factor z minus -2 plus 7i, or this is the same as z plus 2 minus 7i, and this is a factor of the polynomial. And also using our second root, z equals -2 minus 7i, we have another linear factor of z minus -2 minus 7i, and we get z plus 2 minus 7i. Let's say the final root is r. So r is a real number. So it means z minus r is a factor of the polynomial. So this is also a factor, and this is also a factor. Now we can see the polynomial is monic, which means the leading coefficient is 1. So it means we can just write the polynomial as a product of its linear factors. So we have z cubed plus 6z squared plus 61z plus 106. This is the same as z plus 2 minus 7i times z. Okay, actually I made a minor mistake over here. This should say plus 7i. So z plus 2 plus 7i and times z minus r. Now to find r, all we have to do is just look at this constant coefficient over here, which is 106. To find the constant coefficient on the right-hand side, we have to multiply these numbers to get the constant coefficient. What we can do is equate 106 with the product of these three numbers. We have 106 is equal to 2 minus 7i times 2 plus 7i times negative r. So this is equal to, we can do difference of two squares. So that's 2 squared minus 7i squared times negative r. This is equal to 4. So 7i squared is minus 49. So we actually have a plus 49 here times negative r. So it's equal to 50, negative 53r. So we finally get r is equal to minus 2. So minus 2 is 106 divided by minus 53. Okay, so we get the real root is minus 2. And we could even check, we could even substitute z equals minus 2 just to confirm that this is indeed a root. So if we put z equals minus 2 into this polynomial, we have minus 2 cubed plus 6 times minus 2 squared plus 61 times minus 2 plus 106 is equal to minus 8 plus 24 minus 122 plus 106. And this is equal to this is equal to 16 minus 122 plus 106, and this is equal to 0. So we've confirmed that minus 2 is indeed the real root of this polynomial. Okay, that's all I have for this question. So thank you for watching.